Okay, Varves. Who here knows what a Varve is? Um, I've mentioned it a few times. All right, so Varves are, well, I'm holding in my hand a Varve billet, a Varve billet, ladies and gentlemen. If you look really close, you'll see out of focus small layers, many layers. Do you see all those layers? So those layers can be counted. They can be counted using a microscope, which we have in the classroom, but we're not in the classroom right now. So I have actually a photograph of zoomed in look at these layers. Now, is that cool, or is that awesome, or what? This is about 17 times actual size of the thing. And I also cleverly made, well, there's multiple images. You can give these to your students. If you're teaching elementary science in the future, you might want to do this exercise to talk about the age of the Earth, because that's what we're talking about. The age of the Earth, evidence that the Earth is old, or at least that it looks old, right? It definitely looks old. So I have this 17 times actual size. And what do I need to measure? I want to know how far these lines are apart from each other. I need a ruler, don't I? Well, I made a ruler 17 times larger than actual size. So guess what? I can just do this. I can count the layers from top to bottom. Now, can you all see that? How many layers, how many millimeters are there from the top to the bottom? 1, 2, 3, 4, 5, 6, 7, right? About 7? Almost like 7.0. It's pretty exact, isn't it? So what I want to do is follow the instructions on this little instruction sheet. It says step-by-step instructions, directions for doing the Varve activity. I'll read them to you. So examine your sample. Measure the distance in millimeters from the lowest complete band, they mean the complete band of the ruler, to the highest complete band. It doesn't matter what side you consider the bottom and which side you consider the top. We're simply counting the layers of those 7 millimeters. All right, and it says using the magnifying glass, count your layers. And we make you guys use the microscope. And if you put some water, or in my case, coffee on, it makes the bands show up a lot better. See that? Isn't that cool? So you put a little liquid on there, and then you look at it under the microscope. Delicious. And you count the layers. So here it is. So you so it says here, count the layers between the top to the bottom, and calculate the average thickness of a layer in millimeters. And so what I'm going to do is I'll do that. So I counted them earlier. I don't want to spend a lot of time counting them. And I counted 69 bands, 69. And it's like, you have to kind of look across in some places. It's not perfectly flat, right? So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 5, 6, 7, maybe more in there. 14, big fat one. 15, 16, 17, 18, 19, 20, 21, 22, 3, 4, 5, 6, 7, 8. And it's about 70. We'll call it, well, I think I wrote, 69 bands, all right, in 7 millimeters. And so it's 7 millimeters divided by 69 bands is something millimeters per band, right? So it's 7 millimeters divided by 69 bands equals, I wrote down the number. Well, it's basically 7 divided by 70, right? Can you guess what that number is? 7 divided by 70 is 0.1 millimeter per band. You got it? It's 0.101, I think, but we can't really be that accurate with our significant digits. All right, using the shale billet as an example, how many years would it take to deposit a 1 meter sample, 1 meter of this. This is only about, oh, well, 1, 2, 5 centimeters, 50 millimeters. How many millimeters are in 1 meter? 1,000. All right. So let's see. It says here, right here. Recall 1 meter is 1,000 millimeters. So that's 0.1 millimeters per layer and 1,000 millimeters. So it's 1,000 divided by 0.1, isn't it? That's 10,000 bands per meter. 10,000 bands per meter. Don't worry, we'll review the theory behind this in a minute. All right, so the thing you need to know is what forms these bands? Why are they there, right? Have you been wondering? These are annual depositions of sediment. That means seasonal depositions. So just like a tree, like a maple tree has annual rings, lakes and ponds also have rings like this on the bottom. Even in New England, you can find these in mud. You can find varves, and a varve is defined as the top to bottom sediment layer. So let me go and screen share and show you something. Where is it? Where is it? Where does it reside here? Oh, nuts. All right, I know what I'll do. I'm gonna have to edit this part out. Varves activity, Varve. All right, I had the link. I had the link on. I had the rink on. The link on. I'm gonna edit this part out. Hold on a second. And action. So here is some information about these varves, and I just mentioned that they are annual rings. There's a whole cliff here of these. It says the mean thickness of a varve in this particular part of the Green River Formation out in Colorado, Utah, out here. This is massive, right? This is a massive inland lake that formed this shale deposits. This is a form of shale, right? Sedimentary rock. It says a minimum thickness of 0.01, which is a tenth of the thickness that we measured, and a maximum of almost 10 millimeters. So the variation in these thickness layers is quite a lot, but there is an average, and we're pretty close to the average. Their average was about twice the size of our average. All right, and so these are annual. The sediments are deposited in very fine layers, a dark layer in the growing season and a light inorganic layer in the dry season. Each pair of layers is a varve and represents 1 year. 1 year, ladies and gentlemen. So that's the theory behind this. Now, going back to this, we figured out that each meter of thickness is 10,000 layers or 10,000 years. And then it says the Green River deposits in the region from which this varve billet was taken are as thick as 260 meters. How long would this lake have had to be in existence before it permanently dried up, assuming 1 varve layer per year? All right, so let's do that math. Let's do it. It's 260 meters. 260 times 10,000 equals 1, 2, 3, 4, 5, 6. 2, 600, 000. Oh, can you see that? 2.6 million years. Okay, so the Earth looks old. That's what varves tell us, and that's what ancient trees growing out in California that are tens of thousands of years old tells us. Lots of different things tell us that the Earth is old. Our DNA tells us that. Lots of different kinds of things tell us. The ice cores tell us that. Light from distant stars tell us that. So there's lots of scientific evidence that the Earth appears to be old. And I'll take your questions. Unmute yourselves. I'd love to take your questions. Let me cancel the spotlight video and see what you guys have to say. Any questions? Do you get the Varve thing? Raise your hand if you have a question about the Varve thing. No questions at all. Oh yeah, Steph, thank you.
So, the Varves basically is it sediment that builds up over a year? Like it's each year's accumulation of sediment?
Yeah, so this layer was something like maybe 400,000 years ago, and this is 400,000 and one 400,001 year ago. Say this is down, right? 400,002 years ago, 400,003 years ago, 400,004 years ago. You know what I mean?
Mm-hmm.
Like literally, that's like you can date this, date the layers, and you can correlate them with other parts of the Earth and stuff. But yeah, that lake was there for a long, long time. You know, long, long time, and now it's rock. Yeah. So lakes disappear. You know, there's geologic things that happen on a time scale of millions of years that we have no idea about, like mountain formation and the Grand Canyon, stuff like that. Good
So, how
question.
exactly do they take a Varve like from 5,000 years ago? Like, do they just like cut it out of the lake and then it's
Yeah,
kind of
well, it's
solidified?
eroded away at certain places, like where you know water has eroded away the land, or maybe the land's been pushed up, and you can actually see the edges of the layers exposed, like in that Wikipedia page. That's a cliff face, and if you get in there with your little rock hammer, in certain parts of this formation, you can actually find lots of cool fossils of no longer existing fish and different species in the rock itself. So yeah, it's not just the Varves, but it's Varves, it's fossils. Excuse me. There are things called buttes, Butte, that are like these up, they're like pushed up layers that are eroded around, and they sort of stand, and they have cliffs on the edges. It's like the opposite of a fjord. It's a butte, right? Good question. Thank you. Any other questions? You can be featured in the video for all time. Well, that was good. Thanks, Steph. A lot
So
of people
what
have. Go ahead.
so like what to remember about Varves is just like another way of being able to date the earth and knowing that it's old. But we don't have to do we have to know how to like calculate all of that or no?
Sarah, do you need to know how to calculate it? That
Yeah.
is a good question.
Besides just like counting, but like
Yeah.
the
No, I probably won't. I will not ask everyone to do the calculations of most of any kind in the exam if that's like a math phobia type question. But yeah, no, don't worry about that. Although I bet if you were in a calm state, low pressure, and I gave you the data, I bet you could figure it out and do it. I bet you could, Sarah. But no, we're not going to ask you to do the calculation. Yeah, I'm looking at the Wikipedia page. It says stratigraphic range, Eocene, 53.5 to 48.5 million years ago. So you'll notice that time period is like 4 million year window of time. And we said that the cliff is about 2.3 million years or something like that. So the Earth is just dang old, you guys. It's really old from science. We think it is. Anyway, yeah. Good questions, you guys. All right. And scene.